No.
Yes.
No. So I'm missing next week, so. I will say that all that, so.
Just get to that point. All right. Hey, for the first one here, this isn't on your guided notes, but just pay attention here. See if you can identify. You don't even need to write anything down, but just take a look at number one. And just seeing if you know the terminology. What's the perfect square? Okay, you got 4 choices. See if you can figure out that. I got to make a quick phone call. Your parents, talk to them. I'll be right back.
All right, Jordan.
Okay, it's like you divide. It's like you divide by 9, something like that. Something to do with the number 9. I know that.
Well, everything here is multiple of 9.
That's what I'm saying.
I don't know if that is. That is, yeah. That's not what we're looking for, though. I'm looking for the perfect square, Zach.
What's perfect square?
Okay, and now explain to me what you mean by that.
9 times 9.
It's 9 times 9. Okay.
I know.
And we did a lot of this when we did like a difference of squares. Okay. Christian, number 2.
25.
25. Why is it 20? Hey, listen, Christian, why is it 25?
You can times 5 by itself and you get 25.
Okay. And now, what's the vocabulary that we would say? Yes, it's a perfect square. 9 times 9 gives me 81. So 9 is what compared to 81? It's the what? Right.
Square root.
It's the square root. Perfect. Okay. What about down here, number 3? Grant? 256. Why do you think 256?
16 squared.
16 squared? All right. Very good. 16 times 16. Zane, last one?
196.
196. What's that?
14 squared.
14 squared. That's 14 times 14. All right. So we're going to talk about square roots, and we're also going to introduce some more vocabulary. You two done? Are you guys done? Done? Good. All right. Okay, so an expression that contains a radical sign. We might call this a square root sign, but to me it's a little bit easier to call it a radical. Okay, we call it a radical expression. A lot of times, guys, we do a lot of different things with radicals. Okay, they look different from one problem to the next. So we're going to talk about the rules of how to simplify these. Okay, they could look like anything here. These are all radical expressions. We could also, there's even more than that actually. Okay, notice we can have variables. The one thing that we'll get to for some reason in math, and it's actually slowly going away, one thing that we'll talk about is we'll never see a radical in the denominator. Okay, we can no problem having a radical in our numerator if we have a fraction, but we're not going to have radicals in our denominators. Okay, anything underneath that radical sign. Okay, so like here, just the 14, we call that the radicand. All right, it's underneath the square root symbol there. Okay. All right. Again, just like that little warm-up activity, we have perfect squares. We like perfect squares. Perfect squares get rid of the radical symbol. Okay. So again, I would read this as the square root of 16 equals 4, because 4 squared, that's 4 times 4. It's not 4 times 2. And 4 times 4 gives me 16. So 16 is a perfect square. This becomes a heck of a lot easier if you guys kind of memorize like the first 7 to 10 numbers that are on your guided notes there, where you have the square root of 1 is 1. If you memorize 1, 2, 3, 4, 5, all the way through 10 and what they will square to, okay? It makes your life a lot easier as we're doing this. All right, so if you know that 2 squared gives me 4, 3 squared gives me 9, all right, these numbers that are the radicans here, if you know those pretty well, this whole thing becomes much easier. In fact, I would recommend, it's a really good practice when you're doing your homework tonight, write that list down. Write that list down of 1, 4, 9, 16, 25, 36, 49. Okay, that's going to help you. All right, now, let's see what we get here, okay? What is 11 squared? Jordan?
121.
121. Somebody tell me, what's 12 squared? 13?
69.
14. We had that one before.
196.
196. 225. Now you guys might recognize these, but we're not going to expect you to have these ones memorized, okay? And we're not going to take the calculator away from you. All right, 16 squared. 17. 18. 324.
Yeah, 361.
361 and 400. All right. Okay, now it says use your calculator to evaluate the following. All right, all that means is just punch in what it says. Okay? And we are probably not going to get nice numbers with a lot of these. Okay? So. All right, Preston, what did you get? Square root of 432.
20.78.
20.78.
Yep.
All right, now somebody just type in 2 radical 108. And what this is doing is basically saying 2 times the square root of 108. Christian, what do you get?
20.78.
20.78.
Wait, so it's just 2 times the square root of 108?
Yes, but you don't need to type in a multiplication symbol. Okay?
We just type in the square root sign?
Correct. Zane, 4 radical 27.
Ours are different than yours.
Yeah, no, hold on. I'm trying to show you something
Yeah,
here.
this is not on your guided notes. Okay? So, Zane, 4 radical 27, what do you get?
20.78.
All right. I'm sensing a little bit of a pattern.
It's all 27.
20.78. Wow.
I would just say it time.
Take over.
All right. All good?
The point of this is we got how many different answers? 1, 2, 3, 4, 5 different things. They all equal what? 20.78. So I don't want, Grant giving me an answer of 432, and then Rachel says, oh, no, it's 2 squared of 108. And then Jordan says 4 squared of 27. So what we do is we come up with what we call the simplest answer, the simplified form. And that actual answer would be the 12 square root of 3. This would be the answer that we want for our final answer. So we don't want 10 different ones. We want a single answer. Okay, so you don't write, you don't give me an answer of 4/2 for a final answer, because what does that equal? It equals 2. So we take these and we're going to take each one of these and you're going to be able to take it down to that. That's kind of our goal. And that's what we're going to show you here. So now this is what's on your guided notes. So now if you take the square root of 60, it gives you a decimal. So we want to keep it in its easiest form. So here's how we're going to do this.
Here, when we say easiest form, we mean you don't want a decimal. Okay.
Yeah,
Decimals are bad.
right now they want what's called an exact form, which means nothing's rounded off. So start with the square root of 60, and you're going to go over there to the side, and we're going to do a factor tree. Okay. And we did these before. We're going to do a factor tree with 60. And so we're gonna take it down to prime numbers. And so 60 is 2 times 30. And 30 is 2 times 15. And 15 is 3 times 5. Can I do anything else with it? No. So underneath the square root of 60, do this. We're going to write the prime factorization and put it in order that's easiest to do that. So I'm going to write 2 times 2 times 3 times 5. What you want to look for now are any pairs of numbers. Okay, so once you have that, is there a pair, any pair? Pair of 2s, right? I'll circle those. So if there's if there's a pair of numbers on the inside, that means what you do is you take that out and it becomes 1, 2 on the outside. And anything left on the inside, you multiply back together. So if there's only one number left, you leave it. But what's left? There's a 3 and a 5. Multiply that back together. So that's 15. So square root of 60 gives us that decimal. Some of you probably already did that. 1 second, George. And then if I do 2 square root of 15, gives me the same thing. This is the simplified version. Jordan, what you have?
I was gonna ask what if there's no pair in the inside?
If there is no pair, then the original number would be the answer. So a case like that would be square root of 30. And let me just do this real quick. Square root of 30 would be a 2 times a 3 times a 5. No pair, you just have to leave it like that. That would be the answer. Okay, it wouldn't simplify. Okay, but if it does have a pair, the reason this works is because 2 times 2 is 4. And what's the square root of 4? 2. That's why we get a 2 on the outside. So we want to find those pairs. So square root of 17, or 17.
Not gonna do that one.
72. We're going to have to do the factor tree with that. So you got to know your factors. You use your calculators to simplify it. You do not always have to start with 2. Sometimes your factor tree can be smaller if you take 2 bigger numbers and multiply that, but it doesn't matter. Joe?
I did 2 times 36, and then 2 times 18 for 36, and then 2 times 9 for 18, and then 3 times 3.
Okay.
What?
But he's right. 2 times 36. So let's do the factor tree on 72. Christian?
Do we have to write the smaller numbers or the bigger numbers first when we write those?
I would write the smaller numbers first. That is, theoretically, it doesn't matter, but I think it's easier. Then 2 times 9 for 18 and 3 times 3. Now, it doesn't matter what you do. If somebody said it's 8 times 9 for 72, then you get 2 times 4. 4 is 2 times 2, and then you get 3 times 3. Doesn't matter where you start at. But in the end, when we do square root of 72, I got how many 2's do you have? 1, 2. I got 3 2's, and how many 3's do I have? Okay, so that means I got a pair of 2's and a pair of 3's. A 2 has, so this pair of 2 gives me 1 2 on the outside. This pair of 3's gives me 1 3 on the outside. We're going to end up multiplying them together. Don't make it 23. And then I got radical 2 left here. Well, what's 2 times 3? 6. That's going to be your answer. So if you got more than one pair, you got more than one pair, multiply what comes out together. So that's your answer. Now it doesn't guarantee it's 100% right, but if you take 6 square root of 2, and you get that decimal, and you compare it to square root of 72, and they're the same, that's a good thing. Like I said, we had one where we had 5 of them that were all the same. But it's pretty good chance you're okay. Now for that next one.
Okay, real quick, let's do that.
Sure.
Can you scroll up?
Yep.
This is a little bit more advanced here, But if you start here with 2 and 36, and you recognize that 36 is one of those numbers on your guided notes that I told you to kind of memorize those, if you recognize that 36, you can automatically say, well, the square root of 36 is what? So I don't really have to do the rest of this, but you have to recognize that, okay? That means immediately I can pull that 36 out, and then that 2 is going to stay, and I'm done, okay? Now, again, it takes a little bit more recognition up front to see that, but it's going to save you a little bit of time, and your skills are going to get a little bit better.
If you're good with your multiplication, like
Yes.
this is exactly what he said. So, hey, I know 36 times 2 is 72, and I know the square root of 36 is 6. I'll just go right here, and I'll say 6 square root of 2. Saves you a little bit of time, but a lot of you are going to need the tree just to make sure you don't miss something. Square root of 675. You got a 2 on the outside. Okay, I'll show you what to do to handle that. But all right, I'm gonna figure out what 675 is. I know 5 will go into it, but check 25. Will 25 go into that?
Yeah.
How many times?
What?
27 more times.
Hey, take that earbud out. That thing's on, I'm gonna choke you. 27 times 25, is that right?
No.
Yeah.
Yep. Okay, 27 is 9 times 3. 25 is 5 times 5. 5s are done. 9 is 3 times 3. Okay, so when we're done, keep that 2 on the outside. Square root of 675 is I got 1, 2, 3 3s. I got 2 5s. So do I have some pairs? Yes. Every pair on the inside gives you 1 on the outside. Now you already had a 2 there. That has to stay, and anything that comes out has to multiply by it. So I take this 2 out. I got this 3. I take out this 5. And I got square root of 3. So that gives me 30 square root of 3. And that would be your final answer. 30 square root of 3. All right, you try this one. You try 3 square root of 96. We need to get that. Oh, you need that test. I don't know if I got one on my desk. And then we'll do, yeah. I got London. She gave me hers.
You want Form A, right?
I think all I got is Form B. And then we got to switch number 3 on that because it says compound interest and it needs to be exponential decay. Is it over there?
Yeah.
Okay.
That's what I got. I got 5 tables.
There's a lot of 2s.
Take this.
I got 2.
I think it's 12 still.
I think it's 12 squares.
Yeah, answer you just like
Quick question, so for this circle.
Since there's, wait, let me just.
Okay. What's the name of that?
It'll be hard.
Yeah, I was like, you can eat by now. I was like, yeah, yeah.
I'm just saying. 12-6.
My last for hard is I got 6. It makes it hard to find 6.
You done?
Okay. Thank you. That should let you know.
Alright, 5 more minutes.
Hey, let's see, there.
Would this be like lower or just like the simple?
Yeah, so we definitely look at six. Let's see, can that be broken down anymore? Six is 2 times 3, so you can't. Jane Beard, did you get an answer?
Not yet.
Yet?
I'm going, I'm almost
Keep
done.
working. I know you got it.
I have it. Oh, yeah. Christian,
Alright, I think I got it.
What'd you get?
12, whatever that weird
Square root?
square root of 6. Is that right?
Yeah.
Alright.
12 square root of 6. That is, if you got that, you're correct. Now I wanted to go through here. A lot of different paths you can take, but I got 2, 2, 3, 2, 2, 2. You got 1, 2, 3, 4, 5 2s. I still got that 3 on the outside. 1, 2, 3, 4, 5. And then another 3. 2 pairs. So I got a 3 out there. 1 pair means 1, 2 comes out. Another pair needs another 2 comes out. You got 6. And then when you multiply that together, you get 12 square root of 6. Okay. So that's how you want to simplify the factor tree. Now, Christian had a good question. He said, well, can that 6 break down any further? If you did everything correct, it shouldn't. But here's a test. Can you divide a perfect square into that? And if you can, that means it can break down further. So what I mean by that, if I ended up with an answer of, somebody said, oh, it's, hold on, I'm making this 12 square root of 8. I know that's wrong because 8 can be divided by what number? 4. That means that it can be simplified further. Okay, so you might have to do another factor tree on the 8. All right, flip it over. We're going to throw some variables at you. Those are things with x's in them. Now, we were looking for pairs, and I'm going to start this off this way. And actually, let me do something here for 1 second. For some reason, at this point, some of you will now factor tree everything, and you'll kind of lose your mind for a minute. Because what's the square root of 25? You know that, so now you don't need to factor tree that. But if you would, it's 20. It is 5 times 5. So what do I do if I have a pair and I don't have anything left over? It's just 5, and you no longer have the radical. So that happens. So x squared means how many x's do I have? 2 of them. So that means I have 1 pair of x's. So every time I have a pair, what goes on the outside? An x. So the square root of x squared is just x. Square root of x squared. The square root of x squared equals x. The square root of y squared equals y. Okay, because there's 2 of them. There's 2 of them. What about x cubed? Not the same.
X on the inside, X on the outside.
X on the inside, X on the outside. So let me show you what that looks like. Good. You got 3 x's. I got 1 pair. So that pair goes on the outside, but you have 1 left over. So you would say x radical x, or x square root of x. Okay? Now we're going to try and figure out a pattern so I don't have to write this out every time. All right, you hold on to it because I want to keep going. X to the 4th, I'm going to do the same thing. How many x to the 4th means you have how many x's? 4 of them. 1, 2, 3, 4. Okay, now that means how many are on the outside? X squared on the outside. You get 2 of them on the outside. You multiply them back together, which gives you x squared. X squared.
What's in the inside? Just nothing.
There's nothing on the inside. If you have a case where everything is a pair and there's nothing left over, then the radical will be gone. If you took everything out, there's nothing left in the inside. All right, you do x to the 5th and you do x to the 6th. Okay, write it down.
I did.
If you need to write it down. Yep. Yeah. Come back here.
Five is x squared. Or radical back. X six.
And the last one would be x.
Okay. All right, Jordan, what do we get for x to the fifth?
X squared on the outside, X on the inside.
Okay. X squared times square root of x. Jay Lee, how about x to the sixth?
X cubed and then
Just x cubed, because when you circle that. All right, now pay attention. You don't need to see to write this down. Pay attention. See if you can make this jump. What is the square root?
They have one on there.
They have one.
X to the fourth,
No,
y
no,
to the eighth,
X to
How
the
about this?
fourth.
26th.
Oh, what?
Oh, I know.
Wait.
What is it, Jordan?
X to the 13th.
X to the 13th.
Let him believe Jordan.
Because I don't want, do you want to write out 26 X's?
Yeah, but as long as I get the right one.
Okay. You need to learn this little shortcut. And here's all that's happening. Every time you get a pair, you take one out. You basically take the exponent and divide it in half. That's all you're doing. So if you get x to the 26, it's x to the 13th. If I got x to the 50th, how many pairs would you have? You would have 25 pairs. Okay, so it'd be x to the 25th. Just cut it in half. Now, the only thing you got to watch, what if it's an odd number? So 21st.
X to the 10th and then X on the inside.
Cut it in half. So just, you can subtract one. But if it's an odd number, you're always going to have an x left over. Always going to have an x left over. So you got 20 x's. Basically take the next number down, 20. Cut it in half, and then you get one x there. And now, so you do have that one over there on the right, I think, or below there. How about this one here? X to the 4th, y to the 8th, z to the 3rd. You could write them all out, but we don't want to do that. That's too much work at times. Cut those in half. So x to the 4th becomes what? X squared. Y to the 8th becomes y to the 4th. What about z the cubed? Z.
Z, and then Z on the inside.
And then a z on the inside. So you are going to have, if you got an odd power, you're going to be left with something on the inside, regardless.
No, Z to the third would be three Z's on the inside, so there's the two, and you bring them outside.
Okay, now let's merge everything. Let's merge everything. So we're going to throw a number in there, and you're going to throw some variables. 50. Now, if you're getting good, like Mr. Schler talked about, you think of a perfect square that goes into 50.
25.
25. Okay, I'm still going to do a factor tree, but if you got that, so think about how it's going to look. So 50, I got to do a factor tree on that. And I'm going to do 25 times 2. You can. 25 becomes 5 times 5. So now I got a 2, I got a 5, I got a 5. You don't have to, but if it helps you and they're not too big, x squared and y cubed I'm going to write out. If they're like x to the 15th power, I don't want to write 15 x's out. Or if it's y to the 20th, I don't want to write 20. But if it's just 2 of them, and 3, it's not too bad. I'm looking for any pairs. Pair of 5s, pair of x's, pair of y's. So that means on the outside, I get a 5xy. What's left on the inside? 2 times y. 2 times y. All right. Now, those of you who said, hey, 25 is a perfect square, went into 50. So in my mind, I'm saying, all right, 25 times 2. I know the square root of 25 is 5. Boom, that's on the outside. I got that 2 left over on the inside. The thing is you got to pick the biggest perfect square. That one wasn't too bad. Jordan?
Can you do that with a test, or do we have to show our work?
I'm not going to require a factor tree. Okay, if that's what you mean. Like if you can do that, but you just got to be careful. Joe?
16 times 10.
All right, so let's take 160. 16 times 10. 16 is a perfect square. So those of you who are good, understand those square roots, you might be able to move right to the answer. But I'm going to keep going. 16 is 4 times 4, or 2 times 8. 10 is 2 times 5. So 160 is how many 2s? 5. Now I am not going, and then I got a 5. And then I got an a to the 4th and a b squared. I'm not going to write that out. I got a pair of 2s, 2 pairs. I take each 2 out and I multiply them together. That's why I get a 4. A to what power? Colin? A to the second power, and Colin, B to what power? B to the first, or just B? Since those are both even powers, you're not going to have anything, any A's or B's left over. I should have square root of 10. Okay, square root of 10. All right, if you get the next one, I'll take. You can take 2 problems off your homework.
Oh, actually. Yo, you would. That's a 5
But no whining, Josh, when you miss it.
Just kidding.
You miss it.
Okay. All right, see what you come up with. Okay, think about this.
I know, I was gonna write down. So 4. Yeah.
No, you can't. You can't divide 7 by That's
4 plus 7.
Oh.
it was
Yeah.
Just the light inside of the screen.
No crying.
I got
One wrong.
What do you think? Is that it or not?
I get
No. Yeah, you got 4.
Oh.
What do you mean? How do you wrong? How? Wait.
You get like.
Yeah, right?
It's a bot, dude.
Yeah, you get it?
Did I get it right?
No.
No, we
You get it? You get it?
I'm not done yet.
Okay.
Should I get this right?
No.
How far away?
Way off.
Dude.
I mean,
Just do. You never. 56 and 9.
I did, that's what it did.
Well, then it's 9, that goes into 3 and 3. 6, 8, 7.
All right, your answer. Get it right?
No,
It's right there.
Oh, yeah, I got it.
Oh, I got it. I swear I got it.
Mr. D, I just looked at my.
I just finished.
What?
I just.
Yeah,
You did it from the.
That's not fair.
Nice.
All right, so 504.
You copied off my starting 14.
What multiplies to 504?
24 and 21.
9 and 56.
What? Nothing for it.
Or is it five?
Okay, so you get all this. So how many twos? You get 3 twos? 3 twos. 1, 2, 3. 2 threes, right? A 7. Then we got x squared y. So a pair of 2s and a pair of 3s come out. So that's 2 times 3, which is 6, times 5 is 30. Now you need to make sure, see what mistake you made if you missed it. Okay, because everybody's been doing pretty good, and I'm sure it's something you can fix. You still got a 2 and a 7. Make sure you multiply those back together. X squared, I didn't leave myself enough room. That is just an x on the outside. And then that y's got to stay there. Okay. All right, those of you who I said can skip 2, you cannot skip the last 2. Remember, you can skip. It has to be 2, and they cannot be 2 in a row. You can skip the last one, but you can't skip the next last one. Okay, 2 of them, but they can't be in a row.
Wait.
I can skip that one.
Yeah, you can skip 2 of them.
What?